Semua dapat tengok slide? Semua nampak ke slide? Boleh ya?
Nampak.
So, nota pun saya okay. So nota pun saya sudah kasih share dalam ITEL, so you can refer to ITEL. Okay. So our first lecture for today. Actually, this one is a continuation lah from last topic lah, last lecture. Tapi last week kita tiada kan. Still under cement, but this one is strength development of gel structure. Okay. So kalau masih ingat lah, in our previous lecture, we have been talking about the heat of cement hydration. So, ingat saya itu yang paling last lah, heat of cement hydration. So now we are going to continue with the strength development of cement. Okay, so the strength development ini macam dia how the strength they develop lah from time to time. Normally the strength of concrete they increase with time lah. Okay, katalah today this week you hari ni lah you cast your concrete. Lepas tu you cure your concrete for 7 days. Lepas tu check compressive strength. Let's say you will get the compressive strength is maybe 20 MPa, 15 MPa lah for example. And then you continue curing your concrete for 1 month. Contoh 1 bulan, rendam dalam air contoh curing. Then when you check, you test the strength, dia punya strength akan develop. Okay, dia akan increase. Bila kamu kata cure your concrete for 6 months, 1 year, 2 years, dia punya compressive strength keep on increasing lah. Normally, the increment of the strength is because of the strength development within your concrete. Dia ada sentiasa akan develop strength. Okay, so to explain more detail about the strength development of concrete, we will look into development of the structure lah with time. Okay. Okay, so next slide, this one. So this is the graph of development of gel structure. Ni kena tengok lah, sometimes soalan ada juga keluar macam ni lah. Kalau ada soalan keluar gini, you have to understand this graph. Okay, so this graph development of gel structure, it is due to hydration lah with time. So yang 0, 2, 4, 6, 8, 10, 12, this one they represent time lah in hours. Okay, so initially yang kamu tengok first initial hydrolysis, that one macam before you during apa few second or minutes after you mix your concrete lah, you can see that the hydration is high. So refresh balik what is hydration. Okay, so hydration is the cement reaction with water. So that is the process of hydration. Okay, so the initial hydrolysis, you can see that the hydration is high because of the hydrolysis lah. Hydrolysis of what? Hydrolysis of calcium silicate. So when the calcium silicate they undergo the hydrolysis process, so it will produce solution of CH. Kena ingat there are 2 hydration product, okay, which are the CSH, calcium silicate hydrate, and calcium hydroxide. So ataupun kita sebut CH lah. Kalau chemical is CaOH2, calcium hydroxide. So this CH it will gives alkalinity to the cement. So kalau kamu tengok mana-mana freshly cast concrete, your concrete will be in alkaline condition. Okay. So in the first 2 to 3 hour, apa jadi? Okay, within this 2 to 3 hour after you mix your concrete, mix or cast your concrete lah. So within this 2 to 3 hours, the CSH, okay, it will form on the cement grain. Dia macam ni ha. CSH dia akan form on the cement grain. So this is your cement grain. You still must remember lah, you must understand the concept of hydration. Dia kena start at the hydration, it must start at they always start at the surface of your cement particles. You kena start sini. So bila dia start, hydration start at the surface of the cement particles. So the formation of the cement gel dia akan start at the surface of the cement particles jugalah. Logic lah. Okay. Okay. So not only the CSH, it will also form etringite. So etringite is not new lah because we already discussed about etringite in our last lecture. Okay. So hopefully you still remember lah. Okay. So this CSH and this etrangiide, they will coat on the cement particle, especially the C3A lah, especially the C3A. Okay, the etrangiide, they will form on the surface of the C3A cement particles, because we know that C3A dia ada rapid setting. If you don't add gypsum, what happen is that your concrete nanti dia setting faster, so it will cause cracking lah. So that's why we add with gypsum lah. Okay, so it will form grain on the C3A particles. So as the result, the hydration will be slower down. So that's why if you refer to this graph kan, mula dia tinggi. So at 2 to 3 hours this here, kamu tengok dia punya gel, dia punya hydration tu or development of gel structure, dia slower down, they reduce. So this stage, kena ingat, this stage we call it as dormant or induction period. Okay, kita panggilnya dormant or induction period. Okay, dormant or induction period. So this stage is very important because you actually during this stage lah, first few hours after you mix your concrete, after you mix your concrete lah, you can place, you can transport your concrete without your concrete become hardened. Itu yang penting dia, dormant or induction period. Okay, because the formation of the etrangiide CSH, dia akan coating on the surface of the cement particle, especially the C3A, so that dia punya process hydration will be slower down. So meaning that your concrete or your cement or your mortar, they're still in fresh condition. So bolehlah kamu tuang dari sini ke manalah, ikut duration of dia punya setting. Okay, so even you are using concrete at site, so normally it will take 10 to 15 minutes lah to transport concrete daripada actual mixing site to the area lah that you need to place. Okay, so your concrete must remain workable. Dia fresh, so it must be remain workable. Okay, so dia punya application sini kepentingan signifikan, it will allow you to do the concreting work lah. Okay, at 6 to 8 hours, what happen is that the coating on the cement particles, they will break down lah. This one lagi detail in the previous lecture tu, yang ada macam how dia control the setting time, flash setting of the C3A. So within 6 to 8 hours, coating on the cement particles, they break down. Okay, therefore the hydration process will proceed lah, okay, to form etrangiide, CSH and CH. Okay, so these are the hydration product. Okay, so that's why you can see that the graph ascending at this point lah, dia naik.
Sorry dokter.
Apa dia?
Yang keluar di screen kami ini masih di slide pertama.
Oh ya kah?
Ya.
Oh, saya pindah slide kedua sudah, kejap mungkin saya share entire screen kali ya. Dah bergerak kan? Saya stop sharing dulu. Entire screen. Okay. Beritahu sejak kalau ada masalah. Macam mana saya beritahu? Okay, di sini. So saya sekarang di slide yang kedua. So kamu nampak yang ini, slide kedua?
Nampak.
Okay, kita tengok ni lah. So actually saya dah complete, dah explain. Okay, so saya just ulang balik lah. Okay, the first few hours. Okay, first few hours, 0 ni, this one is hydrolysis. 2 to 4 hours around this duration. Okay, we call it dormant or induction period. So this dormant or induction period where the hydration of the cement is slower down because of the formation of etrangiide, the CSH, which will coat on the surface of the cement particle, especially the C3A lah. So they akan reduce the hydration, especially the C3A, because last lecture we discussed that C3A has flash or rapid setting. Kalau kita tidak control, what happen is that dia cepat mengeras, your concrete or your cement will cracking. So ini yang penting lah. The most important is yang awal ni, few hours ni, yang 2 to 3 hours ni lah. Okay, because it will allow you to do the completing work. Okay, and then after that baru dia ada after 6 to 8 hours the process of hydration dia akan continue because of the coating. Because coating of this etrangite and CSH they break down lah during this within this period lah 6 to 8 jam. So dia bila coating breakdown, okay, so dia akan proceed with the hydration process. So once hydration occur, dia punya strength akan keep on increasing lah. Okay, so that is about slide number 2. Okay, so nampak, okay, this one sudah. So nampakkah yang ini?
Nampak.
Oh, okay. Okay, so this one is illustration lah. Okay, illustration of the hydration process. So I want you all to understand lah macam mana tu formation of the dia punya gel formation lah. Yeah, after the hydration occur. Okay, so this one is hydration process and formation of gel. So if you see in figure A, okay, the dark color, this one yang color gelap ni. Okay, this one represent the cement grain. So this one actually example of cement paste lah. Cement plus water only. So the dark color represent the cement grain and the blue color, this one is water. Okay, so figure A is stage where the cement is mixed with water before the hydration start. So next, what happened in figure B? Okay, after you mix your cement with water, of course there will be hydration process lah. So what happened during the hydration process? So you can see the hydration, it will start at the surface. Yang dot ni, that one is represent the hydration process lah. Dia akan ada hydration process at the surface of the cement grain. So you can see that the cement gel actually it will form starting at the surface. Logic lah kan? So because if you have the cement gel macam ni, cement gel, if the hydration they start at the surface, so the gel, cement gel tu dia akan form di permukaan cement tu dulu lah. Okay, formation of the cement gel lah. Okay, so after few hours you can see what happened in figure C. So the grey color here yang represent the cement gel, okay, dia increase in amount. Meanwhile yang black color cement particle, so dia akan reduce in size lah because dia sudah undergo the process of hydration, so they become cement gel. Okay. Okay. So in figure D, okay, the last figure, okay, after the hydration process slower down. Kejap, ada masalah ke tu Abu bunyi balik-balik? Saya nak tengok ni. Semua dengar?
Dengar.
Oh, okay, saya ingat susah saya mau control. Okay, so last figure D, this one after the hydration process slower down lah. Okay, so you can see that almost the grey areas ini, okay, dia become hydrated cement gel. So kamu tengok the cement particles here dia jadi kecil. Okay, because of the hydration lah. Okay, so after the hydration, this cement grain they transform to give us the microstructure of the hardened cement paste. So ni yang kelabu tu kalau ada sampel tu lah susah sikit mau buat online ni. Saya prefer face to face so that I can show you the sample. But I believe all of you must know lah what is apa tu yang apa cement yang hardened cement paste, hardened concrete semua dah tahu juga kan. Okay. But if you refer to figure D, not all the cement particles they are hydrate. Kalau kamu tengok dia still ni grey color, the dark grey color, they still exist in the hardened concrete, for example. Why? Okay, because some part of the cement kan they're not hydrated, they tidak reacted with water. Maybe because that's why we need to do curing. We need to do curing so that the amount of water exists, not amount lah, so that air, water that we use to cast our concrete dia tidak hilang. If you don't do curing, what happens is that water will evaporate. But you design your concrete, you design, you calculate the amount of water, that one is sufficient to produce good concrete. But then because you don't do curing, what happens is that the water inside your concrete, they can evaporate. So insufficient amount of water to react with cement. That's why sometimes there is unhydrated cement particles too, they still ada in your concrete lah. And also not only unhydrated cement particles, but you also can see yang white color. So this white color actually that one represent void, pore void. Ini yang that's why we need to do compaction. We need to do compaction. That one we will discuss in detail in tajuk handling and placing concreting work. So the purpose why you need to do compaction, because you want to remove this air void. Air void is the source of weakness in concrete. So let's say your concrete contain high amount of pore void, so the punya strength will reduce. That's one ini yang problem lah in construction. Okay. So we can identify in particular there are two types of hydrates, or we can say hydration product lah. So we can identify the area here which is lighter, okay, in color. You tengok arrow tu, that one is calcium hydroxide. So calcium hydroxide, it has a very simple formula lah, okay. And this one, this is one of the main phases formed from the calcium silicate, okay. The calcium silicate, it gives alkalinity to the concrete. So boleh tengok lah bentuk dia tu macam mana. Okay, and then we also can see this one, a very fine mixture of calcium silicate hydrate. So these are the two hydrates actually formed during the cement reaction, the calcium hydroxide and calcium silicate hydrate. So kalau kata next time you do research on concrete kan, so you want to see whether they CSH or CSH present or exist in your concrete. So when you cut your concrete, you look through the microscope. So macam mana kita identify? Inilah dia punya bentuk, CH and CSH. Okay, so this is the diagrammatic representation of structure of mortar. So previous we discussed on the cement paste, so this one is mortar. So for mortar, you can see this one, yang yellow color, that one represent, orange color represent sand lah. Okay, meanwhile yang kelabu tu, that one is cement gel. Okay, so this is for mortar lah. Okay, and then for concrete, you can see that the grey color, that one represent the coarse aggregate particles. The difference between cement paste and mortar. Cement paste, there is no sand. Mortar, we add sand, cement and water. For concrete, water, cement, sand and coarse aggregate. So that are the difference between these three lah. Okay, so you can see coarse aggregate in grey color. Yang chocolate tu, light brown color, that one represent mortar. And sometimes in concrete there is also cracking lah. Normally it is due to shrinkage lah. Memang ada juga, okay, in concrete. Okay, so the development of the gel structure actually it start with the formation of the cement gel. Itulah, kalau after you mix and then you leave it for few hours, then dia ada macam membentuk gel, and after that it will harden lah. Okay, so that is the cement gel, formation of the cement gel because of the hydration. And this cement gel, it will turn into hardened cement structure with time. Okay, so in a cement gel, it contains approximately 28% of porosity. So normally porosity, because of ada pore void, okay, that's why your concrete porous. Long time ago, orang semua fikir concrete is durable, but actually not durable. Not durable, it actually depends on porosity, depends on the pore void. Last time dorang mungkin dulu mungkin 100 tahun dulu dorang assume concrete is durable, but then they notice that with time concrete they can deteriorate, they can damage lah. When they study this phenomenon, and then they notice that concrete is not solid lah 100%. Dia ada pore void, So this provide actually yang akan affect durability of your concrete lah. Okay, so this porosity is governed by the gel pores, okay, and also capillary pores. So the gel, pores and also capillary pores. Dia ada pore void lagi. So nanti kita tengok. Okay, so the size of this gel pores is about 150 nanometer. This one in diameter. Meanwhile, the capillary pores, it is much smaller, which is around 2.5 to 50 nanometer lah. So this one 150, yang ni 2.5 to 50 nanometer. So the capillary pores dia lagi kecil. Okay. And the volume of the capillary pores, actually they also depends on the water semi ratio lah, as well as the degree of hydration. So normally if the water semi ratio, you increase the water semi ratio, lagi akan banyak air. Maybe some of the water is not required lah for process of hydration. So what happen is that dia akan menyebabkan formation of pore void. Bila ada formation of pore void, water in the pore void will evaporate. Ada tinggallah lubang-lubang in your concrete. Bila check strength, dia reduce. Why? Because you increase the water semi ratio. Sometimes if you cast your concrete, kita dah tengok what is workable, what is non-workable kan. So let's say you mix your concrete, then dia punya workability is not good. Kamu tambah air. You just simply add water. Of course, it will increase the workability, but in terms of strength will reduce. Why? Because air yang berlebihan tu, dia akan evaporate later on. Not all amount of water is required for the hydration process. That's why you need to do mix design. Mix design kita akan belajar nanti. Okay. And the last one is this one. For this topic lah, okay, is the various form of water exist in the hardened cement paste or concrete. So saya rasa saya cuba ada tanya last time, adakah air tu masih ada ke dalam concrete? Let's say you cast your concrete and then you leave it for 1 year. Adakah tidak masih air dalam concrete? Dalam hardened concrete lah. Okay. So the water exists in hardened cement paste or concrete. There are 4. Okay. They can exist in the concrete in 4 forms. So number 1, water which is chemically combined with the hydrates lah. Okay. They can combine with the hydrates. So this type of water, they are not non-evaporable. Dia tidak akan evaporate unless terbakar. When you building, dia terbakar. So there are certain temperature that will cause the non-evaporable water ni dia akan evaporate. So once this happen, actually your building, of course, it will be in danger lah. Ni they shrink. Okay. Okay. Number 2 is gel water. So what is gel water? So if you refer to this diagram lah, kita refer macam ni lah, imagine lah, this one gel water is water which is absorbed onto the surface of the gel pores. So we have gel pores. So gel pores, the punya size is very small. They're smaller than the pore void. Kena beza. This is pore void. Normally the pore void, the size is larger lah. Ini kalau gel pores, normally dia kecil-kecil. So in the gel pores, di permukaan surface tu, dia akan ada gel water. Okay. And then interlayer water. So water also present within concrete between the intercrystalline spaces within the hardened cement. Saya pun tidak study in detail lah this water form. Okay. So, but this is what the yang sudah investigated by previous researcher lah. Okay. And then the last one is free water. Ni yang free water. This one, it relate to the pore void. The free water which present in the pore void. So this is the type of water that will evaporate once you expose your concrete to environment. If you don't do proper curing. Kena buat proper curing lah. Okay. Okay. So we finish with the strength development. If you have any question, boleh tanyalah sekarang. Kita akan sambung satu lagi. If no question, saya just proceed lah. Masih ada ke semua ni? Masih bawaan?
Ada.
Oh, okay. Masih ada lagi. Sebaik saya dah cakap masih hidup lagi. Masih ada lah kan. Okay. So next topic is binder. Okay, in this topic, we will look into different types of Portland cement, okay, and how to identify different types of Portland cement based on its oxide composition. But this one using the box analysis method. Tapi saya tidak akan ajar box analysis, because saya akan share video lah untuk box analysis, sebab itu saya lebih prefer bagi face to face lah lecture, because it is a calculation actually. Okay, so the first binder, the first topic is subtopic binder. So what is binder? Tapi I believe all of you know what is binder kan? So binder is a substance or material that we use for construction. So this material, it can harden and also it can bind all the materials together. So binder lah. As long as it can bind all the materials together, we categorize it as binder. Tidak kira lah dia cement, lime, gum. So any type of binder that can combine the materials together, itu kita cakap dia as binder. Okay, and the development of binder, actually they start with lime. Zaman dulu-dulu tak ada simen. Kita dia ada simen. They use lime lah. Kita sekarang kan, zaman sekarang. So they use lime as binder in construction. So ni since ancient Roman and Greek lah, they use lime. Okay, so the ancient Roman, for example, they made masonry. So bila kita talk about masonry, macam contoh you construct wall lah, masonry wall. Macam dia susun batu, but they use also binder. But the type of binder they use is lime. Okay, so they actually the whole masonry punya structure, they are similar to modern concrete lah. Only the binder they use lime. Okay, then through the modification of the processing method, so daripada lime, they modify because concrete punya area, they keep on improving the technology. Okay, so in terms of binder from lime, so they are upgrade to natural cement. Modification of the punya processing method saja, so they produce natural cement. So natural cement, this is hydraulic cement. Siapa boleh bagi tahu saya what is hydraulic cement? Apa maksud hydraulic cement? Tidak yang tahu.
Saya tahu betul.
Okay, so hydraulic cement, so hydro relate to water. So hydraulic cement meaning that cement that when you mix it with water, it will harden. We call it hydraulic cement. Kalau you mix it with cement and it will not harden, that one we cannot categorize it as hydraulic. Kita categorize this type of cement as non-hydraulic. So lime actually is a type of binder that is not setting or harden when you mix it with water. Dia normally set because of reaction with the carbon dioxide. So limes tu macam non-hydraulic lah. So that is the difference hydraulic and non-hydraulic. So mana sudah kita cerita. Okay, so natural cement, dia kena buat. Okay, it is made from limestone, batu kapur that has high clay content. Okay, dia ada high clay content. So building yang lime ni, also it is made from limestone, but the content of clay is lower. That is the difference. Bila dia lower, then dia akan jadi non-hydraulic lah. Okay, which is dia tidak akan set and harden.
Macam mati mic, doktor.
Dia pandai mute sendiri ya. Okay, so dengar. Berapa lama sudah dia mati? Baru juga?
Baru juga, dokter.
Oh, okay. So tak perlu saya ulang lah kan. Sampai mana sudah cerita kita ni. Okay, lime, then natural, and then Portland cement. Susah lah tengok begini ni. Okay lah tu. Okay, Portland cement. Okay, kita stop Portland cement. So Portland cement in 19th century. Ini biasanya civil engineer engineer tahulah. Okay, Portland cement was invented in 19th century by Joseph S. Fidin. Tak boleh sudah. Cakap. Joseph S. Fidin. So Joseph S. Fidin invented Portland cement in 1824. Okay, that is Portland cement. Yang Portland cement ni yang jenis yang kita guna nowadays lah, yang sekarang-sekarang ni. Okay, so for example ordinary Portland cement. Pergi hardware tanya, ada simen cap gajah. Itulah tu contoh ordinary Portland cement. So this Portland cement is the most common type of cement that is used lah, in general use lah around the world today, and has become a basic ingredient of kita punya concrete. Okay, Portland cement. However, okay, dia tak stop di Portland cement only. Okay, there's a new development of special concrete, special cement that they counter this Portland cement. Okay, I mean Portland cement, lime, natural cement, and then Portland cement, and suddenly there is another new specialized cement lah, yang dia outshine Portland cement lah during that time lah. Okay, so this new non-Portland cement, dia bukan kategori Portland cement lah, non-Portland cement. They were invented by Jules Bitt. Saya sebut je jalan nama, tak perlu salin lah. Okay, so normally this type of non-Portland cement, it is used for better resistant to sulfate. Okay, and also they have different another type of cement. They call it as Rosendale cement. Okay, but due to its long curing time, this Rosendale cement dia perlu curing time at least 1 month. So this made the Rosendale cement unpopular for constructing highway, bridges. Okay, sebab normally kalau 1 month kamu cast your concrete hari ni, tuang untuk buat bangunan, you have to wait for 1 month. Tidak tahu berapa lama project habis siap. Okay, so that is the limitation lah. Okay, of using the non-Portland cement during that time lah. Okay, so and then many construction firm they turn again to Portland cement. So kita balik guna Portland cement, and finally specialized cement were produced. Okay, by using waste material. Ini yang still kita buat sekarang. Okay, we use waste material such as fly ash, ground granulated blast furnace slag, or GGBS, silica fume. Actually there are many types. That's why next week lah I will prepare a list of pozzolanic sample that we have in our lab, and then nanti saya tunjuk kamu lah. Okay, nanti boleh tengok-tengok. Okay, so itu kategori blended Portland cement lah, when you mix this waste material into Portland cement. Okay, so that is blended Portland cement. So this one yang kira menarik lah. Okay, and the last one. Okay, that is sedikit sebanyak lah binder development in concrete technology. Okay, so the first type of cement that we are going to discuss today is the Portland cement. So kena ingat Portland cement is general type. So under the Portland cement, there will be ordinary Portland cement. We have apa lagi? Rapid hardening Portland cement, sulfate resisting Portland cement, and many types of Portland cement lah. Asal ujung-ujung dia ada Portland cement, that one categorized under Portland cement. Okay, ordinary Portland cement or OPC OPC. Saya tidak letak pula dia punya short name. So OPC. Okay, OPC is the most commonly used cement which is quite useful for general concrete construction. So kalau if you refer to the picture I show you in the slide, orang kuat. So this one not in, tapi dia macam Melayu pula ni kan, orang kuat. Saya pun tidak pernah nampak. In Sabah, I think we have, normally we use simen cap gajah, ada lagi cap gunung, macam ada lagi cap apa lagi saya tidak ingat, tapi these two lah yang saya yang biasa kita guna is cap gajah lah for small consumer. But cap gunung normally the supplier, the cement supplier, they will provide it to the large construction punya project lah. Okay, so cement cap gajah tu boleh tengok di inilah di kedai-kedai, di market, di hardware. Okay. Okay, so there are raw materials. Okay, this one for OPC. Dia punya raw materials categorized as calcareous, for example like limestone, and also argillaceous, for example clay and shell. So calcareous here referring to material which consists of high calcium content. So senang ingatlah, calcareous, cal is calcium, so meaning that they contain high amount of calcium lah. Meanwhile for argillaceous, that one material with high aluminate. So argillaceous dia A, so aluminate, so dia ada apa tadi tu, calcium and aluminate lah. Okay. So all this material will undergo burning process at elevated temperature. So this is the process of producing the cement lah in general, tapi kita specific on the OPC. So you these raw materials, you need to burn it at very high temperature. Okay, and then it will form Portland cement clinker. So nanti they grind, add gypsum, then it will produce ordinary Portland cement. Okay, so this one also we already learned in our last lecture, and I believe all of you know already. We have 4 main compounds in cement. So these 4 main compounds, they must be other in the Portland cement. Any type of Portland cement must comprise of these 4 compounds: C2S, the calcium silicate; C3S, 3 calcium silicate; C3A, 3 calcium aluminate; and C4AF, tetracalcium aluminoferrite. So the different percents ini, okay, the different percent of these 4 compounds, it will produce different types of Portland cement. So here you can see that these are the compounds lah, the amount of cement compounds for OPC. Normally we will kita refer to these compounds lah if you want to detect the type of material, the type of cement in your concrete. Okay. Okay, for OPC. Okay, so you can see here. Okay, so OPC, the percentage of C2S is around 20%. Okay, so the role of C2S is to give slow strength gain to the cement. Ini pun dah discuss last lecture. Okay, slow strength gain to the cement, and it also responsible for long-term strength development of concrete. Okay, so in OPC, the punya amount is approximately 20%, and then C3S is about 55%. So the role of this C3S is for rapid gain strength. Okay, rapid gain strength. Normally it is responsible for the early strength gain. Bila kita sebut early strength, biasa we refer to 7 days lah, 7 days strength. Okay, and then for C4AF, the percentage is much lower lah, which is the C3A. Okay, the C3A content, the amount is 12%. Okay, but 12% is lower than C2S and C3S kan, but because of their punya properties is quick setting, so that's why we add with gypsum. Okay, the quick setting, and also one problem with C3A, it is susceptible to sulfate attack. What does it mean with susceptible to sulfate attack? Meaning that, let's say you have a construction project lah. Before you proceed with your construction project, you have to do the soil investigation. So let's say after you do the soil investigation, you identify that the type of soil for your project site tu, project tu is dia adalah they contain high amount of sulfate. Let's say you use OPC. Okay, you know already your soil has high amount of sulfate, but kamu tidak buat apa-apa, you just use the normal OPC. Okay, what happen is that the C3A in OPC yang 12% ni, it will react with sulfate. Bila dia react with sulfate, what happen is that they will produce, it will form new material lah, new product. They're in the form of gel. So you imagine lah, kalau dalam you punya concrete, kan, tiba-tiba dia ada formation of new gel tu. So what happen is that dia akan give pressure to your concrete, later on cracking. That is what doesn't that is what it's mean with susceptible to sulfate attack. C3A. So dia senang react lah with the sulfate. Okay, and then it will cause damage to your concrete. That's why in certain type of concrete we need to limit the C3A, especially when your soil is contain high amount of sulfate lah. Okay, so bila high amount of sulfate, OPC jangan guna lah. Okay. Okay. And then the last one is C4AF. So the percentage of this C4AF, it is much lower lah, which is only 8%. This is because C4AF has not much important effect to the cement, okay, but the punya role is more to give grey color to OPC. Okay, so C4AF dia bagi grey color to OPC. So the last column you can see that is the heat of hydration, but this one we already sentuh last lecture kan. Okay, but you can see C2S, dia punya heat of hydration 200, 500, 865 and 420 lah. Okay. Okay, this is the table 1 compressive strength requirement of cement. So this one is according to British Standard 12 1991 lah. Okay, so you can see from this table the OPC actually they are available in different classes. So you can see there are many classes there. There are 32.5 and there are 42.5. Okay, and then 52.5 and 62.5. So this value actually it denotes the compressive strength lah. Compressive strength in Newton per millimeter square. Kalau SI Newton in millimeter square lah. Okay, sometimes biasa guna MPa megapascal, but that one is in apa tu unit meter, macam US unitnya unit lah. Okay, and then from this table 1 you can see the compressive strength classes, they are divided into strength 32.5 N, satu lagi 32.5 R, same to 42.5 dia ada N and then there are R. So what is N and R? So N represent normal, R represent rapid. Itu beza dia. Okay, for example, class 32.5 N. So kita tengok first lah 32.5 N. The minimum strength at 7 days is 16 MPa. That is normal. When you check the strength, the strength at 7 days should meet 16 MPa lah, Newton per millimeter square. This is for concrete strength 32.5 N, normal. Okay, but for 32.5 R, you can see that, okay, in 32.5 R, okay, you can see that the strength at 2 days, they just set awal-awal 10 MPa, 10 Newton per millimeter square lah, or MPa. So rapid kan, so at the age of 2 days, after you cast your concrete, when you check, when you test the strength, should achieve 10 MPa. Tu dah maksud rapid lah, macam tu. Okay, but as you can see here, even though they are rapid at the early age, but the maximum or the long term strength they are similar lah, which is 52.5 MPa. So the rest you can boleh tengok lah, boleh faham. Okay, okay. So this triangle, it shows the chemical composition of the ordinary Portland cement. This is for OPC. So you can see that the oxide component, okay, the oxide component, the other C, this one is C, silica, this one is S, and alumina lah. So see, inilah dia punya just simple notation is CSA. Okay, so the grey color here, okay, the grey color, yang tu, yang dia tunjuk grey color, that one represent the dominant oxide. Let's say when you check the the chemical compounds of OPC, so paling banyak C ni, CaO. So that's why the grey color tu yang dia ada arrow biru tu dia lebih ke bawah lah. So the dominant oxide for OPC is more to C lah, which is the calcium oxide or lime. Okay, compared to the silicate and silica and alumina. Okay, so that is the chemical composition based on the triangle. So next, okay, so we finish with the OPC ya. Kita habis OPC. Okay, so next is the rapid hardening Portland cement or RHPC. Okay, rapid hardening Portland cement. So the main properties of rapid hardening Portland cement, they consist of higher C3S content, okay, and also greater fineness. That is the main properties of rapid hardening. So dia ada high C3S content and also the fineness is greater, meaning that the specific surface area is high lah. Okay, so why why the amount of higher C3S is important to produce rapid hardening Portland cement? Why? Because we know that C3S is the main contributor to the early strength, and rapid hardening Portland cement is referring to that cement which needs to set and harden rapidly. So kita mau dia harden and set rapidly. So how you can produce this type of cement? You modify from the OPC to produce rapid hardening by increasing the amount of C3S. Ya, sebab kita tahu C3S is the main contributor lah. So you increase the amount, so the punya concrete, your punya cement will harden faster. That is one way how they manipulate or how they produce different types of Portland cement lah. Okay, and then so RHPC also need to be produced in finer particles. You kena grind lagi halus. Let's say for OPC, the specific surface area is 300 meter square per kg, but for rapid hardening mungkin lagi tinggi, maybe 400 or 500 meter square per kg. So fineness is higher lah. Okay, so that it will contribute to the early strength of the cement. Okay, however, this is one of the problem lah. Because of higher rate of hydration at early age, then the heat of hydration also will increase. Dia cepat kan harden because of higher early hydration. So you must remember that every time your concrete, your cement, they react with water, the process of hydration, it will release heat. So lagi tinggi hydration, lagi banyak heat release. Okay, so this is for rapid hardening Portland cement. Okay, so we can use this, normally use this RHPC. Di mana? Okay, so RHPC we can use, okay, normally used in frosty weather construction, but in Malaysia we don't have this problem lah. Syukurlah. Okay, so there is no problem with winter lah in Malaysia, but in European countries, for example, because they have 4 main season done, so you have to consider to use the rapid hardening lah. And when you do construction in cold weather concreting ni lah. Okay, sebab kalau let's say you use ordinary Portland cement, it will take time for the cement to harden, so dia akan kacau your project. Okay, that's why in cold weather or frosty weather construction, you select rapid hardening Portland cement lah. Okay, and also if you want to remove the formwork earlier, you speed in construction, you want to remove the formwork earlier, so you can suggest to use the RHPC. Okay, so because maybe you don't want construction delay. Okay, so we finish with rapid hardening Portland cement. Siapa ada soalan boleh mencela tanya. Okay, so next is low heat Portland cement. Okay, LHPC. Kalau I say low heat Portland cement, I believe all of you boleh teka lah. Okay, what type of cement we are going to discuss. Okay, this one. Okay. Normally this LHPC is used for large masses concrete construction. What does it mean with large masses concrete construction? For example, yang maksud dia sini construction yang large scale construction lah, construction besar-besar yang di mana you punya structure, building structure dia tebal besar. You can consider to use this low heat Portland cement. Okay, but why? Why we use low heat Portland cement in large masses concrete construction. Okay, kenapa begitu? Okay, so normally large masses concrete construction, of course, dia akan involve large. Ini contoh large concrete structure lah, large concrete structure. Dia bukan concrete yang macam contoh apa tu lantai nipis-nipis 100 mm, 140. Large, of course, the large besar. Okay, normally we know that when there's hydration, when you mix water, cement with water, akan ada hydration, and every time there's hydration, akan ada setting, and after setting, hardening. But this hydration process, it will be accompanied with the release of heat. Itu semua dah tahu tadi kan? Hydration akan ada heat, panas. Okay, but for large masses concrete construction, we know that, meaning that semua dia punya structure tu, this concrete, large concrete will undergo hydration and also will release heat. The issue is, okay, we have exterior lah, outer part. Exterior, saya just tulis EXT. But we also have this interior part. Okay, so the difference between exterior and interior, the exterior part of your concrete, dia akan expose to the surrounding area. So bila dia akan release heat, yang exterior part ni dia akan mungkin kalau berangin apa semua kan, so the heat release will be reduced because of dia boleh remove lah by the winds, for example, compared to the interior. Okay, so the interior here, meaning that the temperature of your concrete at the exterior will be cooler compared to the interior. Yang dalam ni dia akan lagi panas. Dia akan panas. Luar dia akan sejuk. Sejuk sikit lah. Okay, so they will exist thermal gradient, perbezaan thermal, perbezaan suhu. This thermal gradient, it will cause your concrete to cracking because yang dalam ni, the interior part of your concrete, dia hot kan, so normally concrete they will expand, but the outer layer of your concrete, because of dia kena sapu-sapu oleh angin kan, so dia punya suhu tu mungkin sejuk, so dia akan contract lah, for example. Okay, so there exists perbezaan suhu lah, thermal. Okay, so when there is a gradient, thermal gradient, kalau kamu tidak control, what happen is that cracking will occur in your concrete. This is the case when you use ordinary Portland cement. And normally jangan use yang rapid hardening, like rapid hardening lah. Okay, this one kalau mau use the ordinary, dia akan ada masalah macam ni. That's why the solution is you can use low heat Portland cement, di mana it will reduce lah the amount of heat release within your large concrete structure. That is the purpose lah, okay, of using this low heat Portland cement. This one, the thermal gradient, okay, cracking. So how we produce the low heat Portland cement. We know that the C3S and C3A is responsible for faster or high hydration kan. So to produce low heat Portland cement, kita reduce lah C3S and C3A hydration. Okay, cara dia lah, we reduce. Okay, kalau tadi kena take, in order for you to determine lah what type of cement kan, so you use OPC as a tadi tu reference. Kalau let's say the C3S content, kalau tadi C3 for OPC the amount of C3S let's say 55 kan, C3A is 12. So kalau the cement, the chemical composition, let's say the C3S is only katalah 20%, C3A katalah 2%. So that one, this type of cement maybe is a low heat Portland cement. That is how you determine lah. But you have to justify using the calculation lah, the box analysis. Okay, sudah siap tak kita cerita sini ni? Okay, reduce the C3A. Okay, so we use low heat Portland cement in large masses concrete construction. For example, given here is dam lah. Kalau kamu tengok dam, the structure is very large. So if you use normal OPC, you will face with the cracking problem. That's why we use low heat LHPC. And actually there are many example of large dams in yang di negara orang putih lah. Not only they use the low heat Portland cement, but they also use pozzolana, the blended cement. Okay, the blended cement, meaning that they use this waste material, for example, like fly ash, incorporated in the concrete mix design, and then use it to construct this large mass concrete construction lah. So that one also can. Apa lagi? So okay, in large rough footing also, we can use the low heat Portland cement. Okay. So we finish with the low heat Portland cement. So we proceed. Next is the sulfate resisting Portland cement. So sulfate resisting Portland cement also you can detect lah what dia punya purpose. Okay, so the SRPC or sulfate resisting Portland cement, normally we use it in foundation which located in soil containing sulfate attack. Kalau you check your soil ada sulfate, then don't use ordinary Portland cement. Please use sulfate resisting Portland cement lah. Okay, so other than that, okay, so in this SRPC, okay, the C3A in cement, we know that the C3A, because all Portland cement consists of the C3A lah, but in normal cement, C3A in cement, it is very susceptible to sulfate attack. That's why we need to reduce this one lah to produce sulfate resisting Portland cement. Okay, so if you don't reduce, what happen is that it will cause expansion because the sulfate will react with the C3A, okay, and it will lead to expansion lah. Yang macam saya beritahu tadi, extra cement gel, so the cracking, of course, later on they akan spalling lah. So that is damage in your concrete structure. Okay, therefore, we reduce the C3A lah, because we know that C3A not only it cause flash setting but also it's susceptible to sulfate. So kasih reduce. Okay, so C3A should be less than 3.5. Jadi dalam ni kan ditulis lah less than 3.5%. Okay, so this one also can be compensated by increasing the 1% of C4AF lah. Okay, they reduce the C3A but they increase the C4AF. So C4AF is not affected by sulfate. That is how they produce the sulfate resisting Portland cement. Okay, so where we use this SRPC. Okay, so we can use SRPC in foundation which located in soil containing sulfate attack. Benar. Tapi sulfate ni, if you want to know, you have to do the soil investigation lah. Okay, memang kena buat pun. Okay, so other than that, okay, tapi ni pun saya rasa Malaysia dia ada lah kan cerobong-cerobong ni. Okay, cerobong ni dia akan ada apa? Asap tu dia ada sulfur. So sulfur they can sulfate, so they can react lah with your cement C3A. And also structure near the seawater, marine structure, because seawater not only it contain chloride but it also contain sulfate. So kalau macam bridges tu, tengok kalau tidak kalau quality of your concrete kamu tidak design dari awal, propose yang terbaik dari awal lah. So not only it will cause cracking but also corrosion lah. Okay. So that is the application of SRPC in concrete. So saya teruskan lah supaya kita ada sikit lagi, ada sikit topik ni. Okay, saya ingat dah habis tadi. So next is white Portland cement. Okay, so we know that the grey color of the OPC is because of the presence of iron oxide lah. So the C4AF, C4AF tu dia produce this grey color lah. Okay, therefore to produce the white Portland cement, you have to reduce the iron oxide or you have to reduce the C4AF lah. Okay, so minimum normally for kalau tadi tak silap saya OPC it is at percent. So if you want to produce white Portland cement, you have to reduce it to 1%. Sangat rendah lah, so it will give you white color. Okay, So sometimes normally they use the normal clay, the normal clay yang kita guna to produce Portland cement. You also can use China clay. So China clay ni dia almost iron free. So it will give color lah. Okay. I think that's all lah for this one kan. Tapi the setting and strength of this white Portland cement, they are similar to normal concrete lah, normal OPC. Okay, setting and dia punya strength similar to OPC, but harga dia mahal lah, almost double of the OPC. Okay, so this one is the application of white Portland cement to produce white concrete and also for aesthetic purpose lah. Okay, ada lagi? Okay, so sampai sini. Okay, okay. Next we look at this one is not Portland. This one is categorized under blended cement, blended Portland cement, pozzolana and pozzolanic cement. So actually this one, when you mix it with Portland, kita categorizekan dia under blended Portland cement lah. Okay. So first of all, you must know what is the definition of pozzolana. Kena faham what is pozzolana. So pozzolana is defined as a material. So material which able to react with lime, okay, in the presence of water. So lime ni kalau kita ikutkan, dia kena ada simen lah. So pozzolana material, so any type of pozzolana material, you mix it with cement and then water lah. So it will give cementitious compounds. So cementitious compounds meaning that dia boleh bind the materials together lah. So kalau check any material able to give cementitious compound after it is mixed with cement and water, you can categorize it under pozzolana. Lebih kurang macam tu. Okay. Okay, but pozzolana material, it cannot replace 100% the cement. Because kalau you replace, macam let's say you mix pozzolana material plus water, there is no cement, kamu boleh cuba. The next day when you demold your sample, for example, kamu demold the cast in a mold, the next day kamu buka, cuba kamu tekan, dia akan pecah. Dia takkan dia tidak ada cementitious properties lah, because there is no cement. We still need cement lah. Okay, basically pozzolana can be divided into two, the natural pozzolana, this one, and also artificial pozzolana. So this is the example of natural pozzolana. Okay, volcanic ash, tapi saya pun tak pernah lah guna volcanic ash ni. Kena duduk di tepi gunung berapi kali untuk dapatkan dia, tidak juga lah. Okay, so this one is the example of example of artificial pozzolana. So normally in our faculty kan, we use many types of pozzolana, okay, to be mixed with cement lah to produce this blended Portland cement. Okay, silica pun ada. Okay, palm oil fuel ash also categorized as pozzolana, fly ash, GGBS, but nantilah kita discuss details sekejap lagi. Okay, so this is example. Actually I have a sample of silica fume lah, tapi since we only online kan lecture, so I cannot show it to you lah, next week lah. Okay, so first we discuss on, actually we have many types of pozzolana material, tapi di sini untuk for your knowledge only for lecture, saya akan discuss on dua atau tiga kejap. 2 or 3 lah, saya pun lupa. Fuel ash, fly ash, not sure silica fume kalau ada, but fly ash and I think silica slag. Okay, kita just discuss on the main types of pozzolana material that has been commercialized lah to be used in the world lah. So first is pulverized fuel ash or PFS, or sometimes we call it as fly ash. So the main chemical composition actually they depends on the parent coal. So this fly ash actually PFA actually they are waste material from the production ataupun pembakaran coal, arang batu. But in Sabah we don't have this pembakar pembakaran arang batu, something macam tu kah? To generate electricity kan? Last time saya dengar macam ada usaha lah, but then they stop. So we don't have the fly ash lah in Sabah. So very difficult to get lah. But in Sarawak, if I'm not mistaken, yes, they have this fly ash lah. Mungkin orang ada kilang arang batu lah, pembakaran to generate the electricity. Okay. So the main chemical composition for any types of pozzolana, actually they have some the main composition for CaO, SiO2, the SiO2, Al2O3, alumina, silica, calcium, calcium, calcite, semua all they have the chemical composition they are similar with cement lah. I mean the chemical composition but not the percentage. Percentage they are different. Okay. So if you refer to the triangle, you can see here that the main composition of of the fly ash is actually silica. Kalau kamu tengok yang grey color yang dalam triangle orange tu, dia lebih kepada ke atas sikit lah, silica. So we can say that the main compounds for PFA is silica. Biasanya kan one of the properties of pozzolana, dia memang silica content is high. Cement, for cement, the calcium oxide content is high, more than 50 normally lah, 50%, but the amount of silica is low. But for pozzolana, the amount of calcium oxide is low, but the silica content is high. That's why when you mix pozzolana material with cement, it can react to produce the CSS juga. Okay, and then apa lagi? Okay, so this is the morphology lah of fly ash. So if you see from this picture, dia punya shape tu macam sphere lah. Okay, so this is the morphology of fly ash through scanning electron microscopic or SEM lah. Okay, so it's sphere lah, dia bulat-bulat macam tu. Okay, so where do we use this fly ash in construction? Okay. Okay, we can use fly ash to partially replace the cement lah, not 100%, but partially replacing the cement lah to produce fly ash concrete. So it will give benefit, ini yang kena tahu lah. Okay, it will give benefit in terms of improving the durability of concrete. So it can improve durability of concrete. Okay, so you can use fly ash in many aggressive environment such as in the marine structure, sulfate soil, and so on lah. So tadi kita dah belajar in marine structure, sulfate soil. Okay, sulfate you can use the sulfate resisting Portland cement. But now is pozzolana material. Pozzolana material also will improve durability of your concrete. So you can also use it in sulfate soil, for example. So it gives you alternative lah, alternatives selection of your concrete material lah. Instead of using this sulfate resisting Portland cement, so you can suggest to use this fly ash, but provided the fly ash is available lah in your area. Kalau tidak available, payah juga kan. So that one you have to make sure lah. Okay. Okay, so this one only you can refer to BS 3892 if you want to use fly ash with Portland cement in structural concrete. So you can refer to this standard. Okay. Okay, so this one PFA also can be blended with the Portland cement lah. If you see here, dia ada dua standard here, 6588 and 6610 lah. So kalau if you refer to BS 6588, you can mix fly ash with the cement at 15 to 35%. So 15 to 35 ni the amount of fly ash lah. But if you refer to BS 6610, you can use 35 up to 50% of fly ash lah. So dia macam almost half of the cement you can replace. So this one actually in terms of cost dia bagus lah. Because nowadays cement pun mahal. If fly ash is available, you can use this one lah. You can combine the fly ash with the cement to produce the fly ash concrete. Okay, and then but you have to be careful juga. Once you want to use this fly ash, you have to check the punya standard. You have to check whether the fly ash is suitable or not to be used as pozzolana lah. Okay, so to check whether your material, your fly ash is suitable to be used in concrete lah, you have to follow this standard requirement. So kena check lah fineness berapa, hantar lah pergi lab. Kalau tak pandai buat testing, then you can do your own testing lah. So the MgO, okay, the sulfur trioxide, the loss on ignition, semua kena achieve less than 4, less than this one lah. Okay, so kalau you punya specification, you punya quality of your POFA dia within this standard requirement, then guna saja, boleh guna. Okay, okay. Ini apa tadi? Fly ash. So next is the granulated blast furnace slag or GGBS. Okay, so GGBS, this one actually, okay, kalau tadi fly ash, that one is a waste material from coal manufacturing lah. Okay, dia pembakaran arang batu. So this GGBS is produced dia produce dari kilang steel making factory. Dia produce steel. Kalau kamu belajar in civil engineering material, kalau you produce yang bahagian steel tu, metal or steel, so dia ada tunjuk tu ada part of raw material, so after they process dia kena buang. So that is slag lah. Okay, so we can use this GGBS or slag ni sama jugalah, as partial replacement of cement lah in concrete. Okay, okay, so for this one, when you mix slag with cement, so it can produce slag cement. This one if you mix lah, okay. But if you grind the Portland cement clinker, ini dia not the cement yang sudah siap, but the Portland cement clinker with the slag GGBS, so it will produce Portland blast furnace cement lah, PBFC. Okay, that one if you grind it with the clinker. And then if you mix the Portland cement yang after sudah siap lah, okay, after Portland cement yang sudah dalam bentuk powder tu with GGBS together with the calcium sulfate, so dia akan produce super sulfated cement. So many types of cement lah you can produce from this slag actually. Okay. Okay, so if you refer to the chemical composition triangle, untuk GGBS ni, dia ada special sikit. The chemical composition mainly consists of the calcium oxide. So generally the calcium oxide since we required a little amount of lime or to activate GGBS, lime or CaO lah. Okay, therefore some of the researcher they consider this GGBS as hydraulic binder. Dia cakap more to hydraulic binder macam cement lah, but rather than pozzolanic binder. Some of the researcher they claim like that lah, because kalau kita sebagai tahu tadi, Portland cement it has high amount of lime or CaO. So if you refer to this triangle, you can see that for GGBS dia lebih kepada CaO. So that's why they said that this one is more to hydraulic rather than pozzolanic. Macam tu lah. Okay. Okay. Okay, so the proportion of slag, normally we use it not more than 60% lah in cement. What happen if you use slag more than 65? If you use more than 65, then the strength will reduce lah. Okay, but the maximum I think the as mentioned here is 65% and below lah. Okay, so the early strength, of course, it is lower than OPC. Actually, almost all types of pozzolana material, it will reduce the early strength. So your concrete will have lower early strength compared to normal concrete lah, OPC. Okay, because the reason is because we replace partial of the cement lah with the pozzolana. That's why dia punya strength akan hydration product dia untuk early dia akan slower down. Okay, and then but since the hydration slower down, the strength at the early edge is low, meaning that the hydration slower down, so the heat release also reduce. Ini salah satu lah alternative for to replace the low heat Portland cement. Not replace, alternative to choose pozzolana material lah over low heat Portland cement, because the pozzolana material also can reduce the the heat. Okay, apa lagi? Okay, and also it is has better sulfate resistance. So instead of using sulfate resistant Portland cement, you can suggest use this pozzolana, this slag material lah. Okay, and then but the ultimate strength, even though the early strength is lower than OPC, but the ultimate strength they are still similar to OPC. In some cases, dia ada lagi tinggi. Okay, so the proportion of the the application of the Portland and GGBS in concrete, you can see under these three benefit lah. Yes, low heat cement in mass concreting application. So actually you can use it in high weather concreting. Okay, and also in large mass concrete construction because of this pozzolana, it is able to lower heat release in the concrete lah. Okay, and also in many aggressive environment, marine, sulfate, apa lagi, acid attack, alkali attack, alkali also, and okay, so it is a environmentally friendly binder, so meaning that the GGBS or PBFC cement are actually able to improve the durability of concrete in aggressive environment. For example, construction of building near the seawater. So these are the standard requirement lah for GGBS. Okay, so this one, the requirement if you want to use GGBS with Portland cement, so kena check lah the properties. Okay, and this one, if you want to interground the Portland cement with the GBS, also you can see in BS 146. Okay, so I think that's all. Okay, so that's all our lecture for today lah. For box analysis, that one nanti saya akan share saya akan share apa tu online lecture lah. Masih ada ke semua ni? 55 ada sudah. Ada, okay. Stop sharing. Ada soalan? Saya akan share kita punya attendance. Cuba. Okay, so please mark your attendance lah. Saya dah share di chat box. So if you have any question before we end our lecture, tolong tanya lah sekarang. So this is week 4. Suppose kalau based on our syllabus kan, saya akan release assignment for week in week 4 lah. Kita tengok dulu. Kalau tidak week 4, in week 5 lah. But one of the assignment question is related to box analysis. Recording has an expiration date. Bukan. So dapatkah? Dapat mark attendance? Kalau dapat, mark saja attendance kan, nanti saya check.
Doktor, attendance tu tiada dekat chat box.
Meeting chat pula tu saya kasih chat. Kau dan terhilang mana? Tiada? Saya letak dalam grup lah kan? Senang. Tapi nanti dalam grup yang dah hadir pun nanti klik. Okay, kejap lah. Cuba kamu masuk dalam grup, WhatsApp grup. Cuba cek ni. And then hopefully okay lah ni semalam saya pergi prepare. Semalam ke saya prepare. Okay, cuba cek kalau ada masalah beritahu. Okay, boleh mark attendance. Saya pun tak mengecek ni, buka dalam ni.
Boleh doktor.
Oh, okay. So boleh siapa yang sudah mark attendance, kalau tiada soalan boleh left lecture room lah. Ya, sama-sama.
Thank you, doktor.
Thank you doktor.
Thank you, doktor.
Selamat bercuti kelas